Hello, box plots. Now, not hello box plots, hello to you. We're doing box plots right now. Supposing you have a ready-made cumulative frequency diagram and you're asked to do a box plot from that. If you look at what we got there, we have two box plots showing the ages of all the people in two villages. We've got Ayton and Beesby. Ayton and Beesby. I want to show how these numbers relate to a cumulative frequency diagram. So if we look at Beesby, for example, we have the youngest person there, which is the bottom of the range. We have the oldest person there, the top of the range. We have this part of the box plot there representing the lower quartile, this part representing the upper quartile, and this part, not surprisingly, represents the median. So really we can extract the information from cumulative frequency diagrams to create box plots, and therefore if we have two cumulative frequency diagrams comparing two similar sets of data from two different locations, in this case two villages, then instead of trying to put it all on one single cumulative frequency diagram on one set of axes, it would get very, very untidy. So hence box plots used to extract the key data and place them side by side. It's a very powerful visual image of what's happening in the two locations. Alright, so and in fact, if I wanted to work backwards, I can actually create cumulative frequency diagrams for these two villages just based on the lowest value, the highest value, the lower quartile, the median, the upper quartile. I will only have 5 points to plot, but at least I get the overall the key data expressed as part of the cumulative frequency diagram. So let's just jump straight in, complete the table for the two villages. Okay, Ayton first. We've got the lowest value, the youngest is going to be 28, so that's the minimum age there. See how it all relates. The maximum age there is 70. Two villages. The lower quartile, I make that 35, between 30 and 40, so that's going to be 35. It's the lower quartile. The upper quartile is going to be 63. I can see that quite clearly. And the median value, or the median age, is going to be 56. Now, I could have worked out the interquartile range. That's not what this is about. It's about actually extracting data from a ready-made box plot. Now, Beesby, the youngest is 2. The oldest is 52. The lower quartile is going to be 14. Upper quartile 43. And the median age 28. Yeah, accept that. Right, that's all the data extracted from the two box plots. So just remind you, that's the lowest value, that is the lower quartile, that is the median, and this value here is the upper quartile, and same for Ayton as well. Right, compare the ages. Well, let's just take a look. In fact, I will work out the interquartile range, so let's do Ayton first. This is a great way to do spread, remember. Ayton and Beesby. Right, what we got there, we've got the interquartile range is going to be upper take away lower, so it'll be 63, take away 35, and that will give us, let's get a machine quickly, I don't want to make a mistake, 63 take away 35, age range of 28 years. And Beesby, we've got 43, it's the IQR again, 43 take away 14, that's going to give us 29. Okay, very little difference there in the spread. What else? Right, let's compare the ages. Straight away I can tell by the interquartile range there's very little difference in the spread of ages between the two villages for the middle half of each of the sample taken. What about the overall spread? So we've got here 70 take away 28, we've got there a range of 42, an absolute range, and for Beesby we've got 52 take away 2, which is 50. So on the basis of the range alone, we have a wider age range in Beesby compared to Ayton, and in terms of the interquartile range there's very little difference of the spread of ages for the middle half of the sample taken from each village, and that's the comparison of the ages. Now, as a wider discussion, you can see that Ayton, with the youngest age of 28, has no children at all, because if you're 28 you're not a child. You may act like a child, but that doesn't make you a child biologically speaking. Beesby definitely does have some children. The oldest member of the village in Beesby is only 52, therefore the oldest member in Ayton is older than the oldest villager in Beesby, and the youngest person in Ayton is a lot older than the youngest person in Beesby. And I've compared the ages. Now in terms of the median, look at that. Put it down here, shall we? So if we look at the median there, we find that on average, if we use the median as a measure of average, on average the people in Ayton are a lot older than the people in Beesby. In fact, you can say that on average the people in Ayton are twice as old as the people in Beesby, taking the average there. And as you can see, look at the median there. That's a lot further along than this little bar here, which is on 28. Alright, so that's 28, and that is 56, and it goes about twice the age. Of course, not everyone's twice as old as everyone in the other village, but on average that's what you've got, and that's compared. Next part says the cumulative frequency diagram shows, and I think that's going to be question 5. The cumulative frequency diagram shows the waiting times in the main post office. So if I put the word main up here, then we know that's what we're talking about. And below we've got the waiting times in a village. I'll put village here so I don't lose track of what's going on. And I've got to compare the waiting times. Well, I've got a ready-made box plot here, so let's just do the village, and let's just do the main post office here. Now what do we want? We want to get the least waiting time, the maximum waiting time, the lower quartile, the upper quartile, the interquartile range, and the median. Once we've got that, we can compare absolutely everything. So let's try and draw some crude little lines across here just to separate off. I think I use my line facility. There you go. A lot easier, isn't it? Not very pretty, but easier to do. And the medians we'll do in a minute. Okay. Right, back to that. Now let's just fill up the details for the village. Let's use blue. Right, we've got for the village there. Village, we've got going up in 2, so that's going to be half a minute, would you believe? My goodness, look at that. So half a minute, so that's going to be 30-second wait. Longest waiting time is going to be 12.5 minutes. I don't like mixed units, but okay, let's go for half a minute, and then no one's going to complain about it, are they? So half a minute, it's 12 minutes maximum. Lower quartile is going to be 2-4. No, it's not. It's going to be 2. That's it. Lower quartile is 2 minutes. Upper quartile is going to be 8 minutes. Interquartile range 8 take away 2, 6 minutes. And the median is going to be, so that's going to be 3-4 minute wait on average. Now we'll do the same from the cumulative frequency diagram, and therefore I'm now going to demonstrate how you get all these numbers from that. You know how to plot these things, and so now I'm going to show you how to get all the quartiles from it. Again, using the line facility. Work with red, I think. Alright, so the least value, I'll do that in a minute. Right, median, right, 50 people, the middle of that is roughly 25, so if I take that there and then bring it down here, very, very hard to judge this, honestly. I'm going to call that 5 minutes. That's the median. Lower quartile is gone, the 12.5 is approximately there. Again, very, very difficult to see what's going on. I'll judge it later. 3/4 is 37.5. So 35, I'm going to put it about there. Again, forgive me if it's not 100% accurate, it's very hard to do it, but again, you've got to do with what we've got. So let's just do the writing of it now. Right, lowest value, least waiting time, looks like about, I'm going to go for a minute there. Maximum waiting time is that point there, drag it down to 16 minutes. Lower quartile, I'm going to go for 3 minutes, again very hard to tell. Upper quartile is that one there. It looks a bit like 6.5 minutes, doesn't it? The interquartile range, that take away that, 2.5 minutes for the main post office, and the median waiting time I'm going to go for 5 minutes. Alright, is that all the data? Let's take a look. Right, maximum minimum. So in the village we have a range of, an absolute range, 12.5 to half, that's going to be 12-minute range. And in the main post office, 16 takeaway 1, that's going to be 15 minutes. So that's the first bit of data. Interquartile range, let's just compare the IQRs. Then I'll speak out what we see. IQR 6 minutes, and the main range, sorry, the main IQR is going to be 2.5 minutes. Then we compare medians, obviously. Me summarising the data, aren't I? Village median 4 minutes, and the main post office median waiting time 5 minutes. Now I've now got to go and compare the waiting time to these two. Okay, I'll do that just by speaking it. Let's look at the range. In terms of the range of waiting times, the spread of waiting times, there is a greater variety, a greater spread of waiting times in the main post office compared to the village. But when it comes to the interquartile range, for the middle half of waiting times, there's a much narrower spread of waiting times in the main post office, and there's a wider spread of waiting times in the village post office. So let's just go for the biggest. So in terms of the middle half of the sample taken, there's a wider interquartile range, a wider spread for the middle half of the population. But for the absolute range, there's a wider spread of waiting times in the main post office. Now, in terms of the median, there's very little difference in the waiting times between the village and the main post office. So if there's 1 minute difference there, we're going to say there's no difference in the average waiting time, judging by the median. I think that's it. I don't think there's any more. Yep, that's it. So thank you for listening. Just go back there.